All right, hey guys, I thought I'd take a minute to kind of walk you through what I'm doing here. This is for Matthew over at Kings 5 JK, and I'll have a link to his channel in the description and a card on the screen. But this is he's big into the Jeep scene and gets involved in a lot of accessories and things like that for Jeeps. And this is going to be a roll bar accessory for a Jeep, and it's going to kind of serve, I think, as a clamp. But it gets some, so it's 2.3 inches on the inside, and then the hex, I'll have to check it real quick. Let's see what that's supposed to be. 2.8 inches on the outside, so you end up with about a half inch of material there, half inch thick this way. So you can see I cut two of these out. The first one I had the lead in and lead out on the ID, and it just left a funky spot there that I thought was going to probably cause some kind of a problem. So I went ahead and moved the lead in and lead out to the outside, and it does the same kind of thing, although not as severe. And this has got to get holes drilled and tapped around the outside of it. We're going to do that on the mill. But I just, I don't think that this will work very well for that, because I think there's going to be another plate that comes up and gets bolted to it. So what I'm going to do is redraw this. And so this is... yeah, 2.86 roughly on the outside and 2.3 on the inside. So I'm going to redraw it and make it as one solid unit, cut it out as one solid unit, and then we're going to mill off. Oh, and I'm going to make the OD, or the outside, it's not really a diameter, but the outside shape, I'm going to add a 1/4 inch to all the way around. So it'll be ended up being a half inch bigger. And then we're going to mill off a 1/4 inch so that we can get this draft out of it. And 1/4 inch may be too much. I'll look at it and see how much draft is in it, and then take that amount. But I don't want to undersize it. So let's go take a look at the CAD on it, and we'll go from there. All right, we are at the MacBook here, just firing up Fusion 360. We'll switch over and give you a look at what we're doing. All right, here we go. So we will take a look here. This is what Matthew sent me in Fusion 360. And this is the work that he came up with what he was looking to do. And the cool thing about Fusion 360 is you can share a folder. And so this is a folder that he's got. And I'm just, looking at it here. He shared it out to me so I can open it up in Fusion and see what he did. And then I could just take it all the way back to the initial sketch here in 2D mode and look at that and convert that to DXF and cut it, which is what I did. So, but you see what Matthew did here is he has he has the full design. He shows all of the 1/4 inch 1/4x20 holes in it, and which from a CAD perspective, I don't really need that, because I'm going to manually drill and tap those. I wish I was CNC milling this, and if I was, then this would come in handy, and we'd go up here and switch over to the CAM model and do the CAM and all that. But so this is what we tried, and cutting it in two different pieces was problematic for a couple of different reasons. So we're going to re-sketch it and recut it. So I'm going to go up here and just go into, I think I've actually got another folder for King's JK from some people. Yeah, here we go, Matt's King's Disaster. So we'll open that. This is some stuff I've done. There may be some stuff in here that's not needed, but we'll go and create a new sketch. Oh, we'll go new design, and we will sketch a, let's see, we're going to sketch we'll just hit C for a center point circle. We're going to pick that plane, and then we'll anchor it down to the center. and this is going to be, I'm going to make this 2.28. All right, so we have that, and then we want to go and create the hex. Let's see, and I have to remember, I think it's going to be this one. We'll start that from the center as well, and it is going to be 6 sides, and it's given us that. And we want to come out, the current one is 2.8, so we want to add a ½ inch to that, so we're going to make it 3.3. So now we have a lot more wall thickness out here that we're going to end up milling off. All right, so that's it. That's all we have to do. We're going to take a ½ inch off all these sides, and we'll be good to go. All right, so I am going to walk you through real quick the SheetCAM cam setup. It was interesting. I had a guy the other day from Autodesk Fusion 360. He was the cam manager, and he noticed in a video that I did the CAD in Fusion 360, but I didn't show the cam work, and was wondering if I used Fusion 360 for cam. And the answer is no. And I mean, he seemed like a nice guy. I just left him an honest comment about it. SheetCAM is just so simple and so easy, and it seems like a lot of stuff in Fusion 360, and especially probably because I'm not that familiar with it, it just kind of fights you. You know, you're always just fighting against stuff and so forth. But we sneaker netted this over here from the computer out there, and I'm just taking a screen capture from the video camera, not an actual screen capture session, because I am not really set up to do that on this Windows computer. A couple times when I've tried it with some software, the screen capture software didn't seem to want to play that well with this. So anyway, you can see our part here, and let's just make sure we got this right, because that looks awful small in there. Yeah, I mean, it's, you know, 2.3, so we're good on that. And then the outside of this, just double check it. Sometimes when you do an import, you know, it will, yeah, we want to go roughly about there. So that, yeah, I think that's the issue. It's definitely too large there. So let me go see what I did with the cam, and I'll bring you guys back. This is the kind of stuff that, you know, when you're in a hurry and you're making stuff, you look at it, you know, and that's why you do a little double check, because something didn't look right about how big this external part here is, just looked out of proportion. So I got something wrong in it. So let me go back and address it, and I'll bring you guys back here in a minute. All right, we are back now. I think I found what the issue was. So you know, when you're creating a circle, you put in the dimension of the diameter, and when you're creating this hex, the dimension that you're putting in, if you put in the diameter, it's basically going to double that. So what you have to do is put in the dimension from the center to the edge. In our case, it was 1.65 is what we needed, which is half of 3.3. So I've got a new file, so we're just going to go here, and we'll say new job to kill that one. No, we don't want to save it, and we'll go back and do import, and here's our newest one, so we'll click that. You can see it looks much more in proportion. So if we go from here across the center line to there, it should be somewhere around 3.3. I don't have it directly on the center, but yeah, now we're looking at something that looks more like what we're trying to make. All right, so from here, we just want to go in and we got to put the inside on its own layer. So we'll go new layer and call this inside hole. And then we'll create the toolpath cam for that. So we're going to go inside offset, inside hole. And we know the kerf on this being ½ inch with an 85 amp tip. Let's go look at that real quick. I keep a little cancel out. A little quick reference guide here on the desktop. So we're using an 85 amp tip, and we're using 1/2 inch material. So we're looking at the wrong sheet. Let's go kerf widths. So again, 1/2 inch, 85 amp shielded over here to 1/2 inch, and we see that that's 90 thousandths kerf. So we'll go back. We will create our toolpath, and again, it's going to be inside offset. It's going to be inside hole, and here we're going to select the tool with 90 thousandths kerf. On this, I do not want to do an overcut. On anything thick, an overcut really kind of hurts you, and I'm not going to put a lead in and lead out on this. Is not well, yeah, on this we do want to arc that back in, so because it's on an inside cut. So now we have our path. Actually, the better way to do this is this. Have it start as close to the center as you can, and we'll just make it, we'll make it 1 inch. That should be good. So now it's going to start, do the circle, actually going this way, and it's going to lead back in. So now we want to create the external cut path. So outside offset, this is the default layer, which is going to be the outside, and 90 thousandths is going to be the same. And we'll create an arc, lead in and lead out, and because we're going to mill this off, it doesn't really matter. Actually, we can make it 1.25 on both of them, so just a little 1/8 inch lead in, and you see where it stuck it there on the corner, and we'll just move that to start there. So you can see the green indicates it's cutting on the inside of the line for the inside, and the green on the outside indicates that it's cutting on the outside of the red line. So we are all set. We'll run the post processor, and we will fire up Mach 360, get that opened up, and then we'll be good to go. I got to turn the table on, but just thought I'd walk you guys through that. All right, let's see, grab an end mill here. I know these are 4 flutes, 7/8, and I've got a 1 inch 4 flute as well. So I think we'll grab this one. I've not actually used this one before. All right, so we'll get it chucked up here, get things swapped out so we can start milling this. All right, so I just touched off on that, and we've zeroed out the indicator. And now I'm going to come up 1/4 inch. So So 100 thousandths, 200 thousandths, and 250 thousandths. So we're going to go ahead and mill that off of there. I'm going to mention something real quick. The feed rate, you know, I'm manually feeding it by hand. I'm watching the chips come off of it, and if you can see, that one right there is really silver looking, and then hopefully these aren't going to be hot. Find one, and you see this one has a gold looking color to it. If I can get it there, you can see it. Just starting to turn blue, and then I got some others that are just solid blue, like that one. So the feed rate, you know, I'm watching the chips come off of it and adjusting how fast I'm pushing it into it based on the color of the chips that are coming out. And you want it sort of in between the gold and blue. Blue is okay, you know, you're starting to push it, but the you want to see the heat get into the chips. You don't want to see the silver ones because the heat is not staying in the chip. It's transferring into the cutter. All you machinists out there already know that, but I've got a lot of people watching this channel that aren't machinists, so I thought I would mention that. So we've got 3 sides milled, and now we're going to have to adjust and take another 1/4 inch off to do the other 3 sides, because now it's going to sit down in there lower because we've now milled off these 3 sides. So let me get this readjusted. We'll do the same thing. We'll set the indicator up, lower it down, and we'll mill the other 3 sides. All right, we went ahead and milled the rest of that off camera. I discovered that, I'm going to summarize this at the end, but I discovered I'd made a mistake. While I was milling, I was thinking about drilling and tapping, and I noticed that I was making a 6-sided unit instead of an 8-sided, which is what his original design called for. And I've worked with him on this before, and I had that same issue. I kept wanting to make it 6-sided, but anyway, we recut it again and milled all 8 sides. I took a 1/2 inch end mill and chucked it up in there, and centered up the end mill in the vise, the 1/2 inch end mill being the same thickness as our piece here. So we should be dead center, or really close enough for what we're doing on this. It's within a few thousandths. I mean, I could have indicated it in and used an edge finder and all that, but just to do something quick, this will work well. So now we get our Edge Technologies vise stop clamped in. So we're gonna first of all use our spot drill, and let me move you around a little bit better. And we'll lower the knee down. So these are going to be 1/4-20. So we're going to spot it first. Get a little bit lower. let's sure we got the burrs off of it. Butt it up against our stop and tighten the vice jaw. And the good thing about this setup here is I'm not even going to really take any measurements, and we're going to use the stop and rotation to get them all drilled symmetrically, at least the two on this side, and then there's two on the bottom flat that oppose it. So we're going to spot it, drill it, and then tap it, each one in each of the positions, and before we rotate. I'm just putting a witness mark on that. So we got our drill and tap index here. We want to get a 1/4 20. So it's number 7 drill and a 1/4 20 tap. And we may have to lower this knee just a touch more. Alright, so we're going to put this in low gear and slow it way down. I should have chamfered that before I tapped it. I'll do all the rest, but we'll go ahead and chamfer this one real quick. Alright, so we'll just flip this around. Make sure we got no chips down there. Flip it around the other way. And this will ensure that we are evenly spaced. Spot drill. Some people are going to say, oh, you didn't have to do the spot drill. Why'd you do that? Nah, I'm just doing it, you know. Well, when you're drilling and tapping, with a rigid setup, you don't want to take any chances on the drill bit wandering, so we're just taking an extra second to spot it. So we'll put the chamfer on it this time. Back in low gear. And we'll put our tap in. Get this really, really tight. Some people have asked me, why do I tighten the chuck jaw up in different positions? A lot of you old school guys know this. I can't remember who was it. Somebody pointed it out to me one time, that if you get one jaw, get the chuck tight from one position, if you move it around and tighten it again, you'll be able to tighten it a little tighter. All right, so I'll show you. I'm not going to show you the rest of this. I'm going to go ahead and finish this up, and then the last operation we have is splitting it in half, and I'll come back and show you that. So I'm going to just repeat the process, drill these holes. All right, here we are over on the dual vertical bandsaw, and you can see I did a little layout. I'll try to get it at the right angle. You can see the split line, so we're just going to split this in half. And I was afraid of that. I was bracing for that to do something disastrous. I figured it would be under pressure there to want to clamp down on it. And sure enough, it did. But we'll cut the other side now, and that'll open it up. All right, just use a push block there. I don't want to get my hands anywhere near this thing. It's a Widowmaker for sure. So there's our two halves, and this is going to be the end of part one. These are going to be the end caps for, take a look on the screen, for the next part of the build here. So we'll have a second video coming out in a few days showing the finished product.